Hello student, today we are going to discuss a special type of bonding, that is back bonding. Before that, this topic we have already studied about what is bonding, what are the type of chemical bonding. So this topic comes under a topic some special type of bonding, and every year one question from this topic comes in JEE Mains and JEE Advanced. So here we have to discuss what is back bonding and what are the condition of back bonding and what type of question are asked from this topic. So first of all we have to discuss what are the condition of back bonding. So for back bonding, in bonding atom, one bonded atom must have lone pair of electron and other atom must have vacant orbital. And second condition is one bonded atom must be of second period and other bonded atom must be of second or third period. So let us discuss with an example. Suppose we have to take an boron trifluoride, that is BF3, and just check in this example is there is back bonding or not. So first we have to write down the configuration of boron. The atomic number of boron is 5. And if you write the configuration of boron, it will be 1s2, 2s2 and 2p1. So first I have to check these two conditions are applicable here or not. So if we write down the configuration of boron in orbital diagram, here in 2s orbital there are 2 electrons and in 2p orbital there is 1 electron. And for bonding, this electron must have excited into higher energetic orbital and there is 3 unpaired electron in boron. So first condition will be satisfied in case of boron trifluoride. So let us discuss is second condition is also present in this compound or not. So first we have to draw the structure, write down the configuration of fluorine, and the electronic configuration of fluorine is 9. And if you write the configuration, this is 1s2, 2s2 and 2p5. And if you draw the orbital diagram, it will be represented as 2s2 and 2p5 is this one. Okay. And we know that halogen always forms single bond with the other element. So this outermost unpaired electron participate in bonding, and the remaining these 3 paired electrons are treated as a lone pair of electron. So in this compound BF3, these both two conditions are satisfied. So we must say that in BF3 there must be back bonding. So just check how we can find there is back bonding or not, and what are the different conditions for the back bonding and what is the result of back bonding, what it affects in that compound. And suppose as bond length increases or decreases or hybridization changes or not. So first we have to draw the resonance structure or resonance hybrid structure of this compound. So in each fluorine atom there will be 3 lone pair of electrons, and in boron there is a vacant orbital. So this lone pair is donated by fluorine atom and it will accepted by boron atom, and here it forms a partially double bond character due to back supply of electron, and this term is known as back bonding. If you draw the different structure of boron trifluoride, in first case if we consider the lone pair is transformed from this fluorine atom, in second condition if we consider that lone pair is transformed from this fluorine atom, and in this condition if we consider that lone pair is transformed from this fluorine atom to boron atom, we must say that this one is resonance hybrid structure, and resonance hybrid structure contains all canonical form of this structure. So we must say that the bond between boron and fluorine is not single bond, it will have partial double bond character. So if we consider what are the bond order of boron trifluoride in BF3 compound, so we have a formula in case of resonance hybrid or resonance structure. The bond order is equals to total number of bonds between 2 atoms in all resonating structure divided by total number of resonating structure. So if we consider these 3 structures, there are total 4 number of bonds between boron and fluorine atom. Yes, this one is single bond, this one is single bond, this one is single bond, but due to back bonding, this bond is partially double bond or character is there. So total number of bond between two atoms is 4 and total number of resonating structure one is 3. So the bond order of BF3 is 1.33. It will not be single bond. So what are different type of question asked from this topic? First question comes from back bonding strength. Suppose we have 4 examples, BF3, BCl3, BBr3 and BI3. And if we consider that where the strength of back bonding is high or where the strength of back bonding is low. So first we have to consider these two conditions. These two conditions are applicable in this compound. So we can consider that the strength is increases or strength is decreases. Here must consider if in case of BF3 we already discussed that in BF3 there must be back bonding. But if you consider in case of BCl3, Cl is third period element. So in this case it will also be some parts of back bonding will be there. But in case of BBr3 and Bi3, bromine is a fourth period element and iodine is fifth period element. So there will not be any back bonding there. And for these two compounds there will be back bonding. In first case BF3 will have a highest strength of back bonding and BBr3, BCl3 there will be. So it will be BF3 will have highest back bonding, then BCl3, after that BBr3 and after that BI3. One more question I have to discuss from today's class, order of Lewis acid. So we know that the definition of Lewis acid, the lone pair acceptor electron is known as compound is known as Lewis acid. So in case of BF3, boron already accept lone pair from fluorine atom, so there will be no any vacant orbital. So BF3 is a poor Lewis acid. And in these cases, in Bi3 there will be no back bonding takes place. So Bi3 is better Lewis acid. So if we consider the order of Lewis acid for these four compounds, boron triiodide is better Lewis acid than boron tribromide, and boron trichromide is better Lewis acid than boron trichloride, and boron trichloride is better Lewis acid than boron trichloride. Okay, thank you student. We will discuss this topic.